Okay, number 6. True or false, if the graph of a function is concave down, then f prime is negative. Okay, so I always need to look at a picture. Here's a graph that's concave down. So, is f prime always negative? Okay, well remember, the f prime is the same thing as the slope. So you see here going up, my slope is positive, and here going down, my slope is negative. So here f prime is negative, but here f prime is positive. So if the graph of a function is concave down, it doesn't always have to be, f prime does not have to be negative. So that's false. Okay? If the graph of a function is increasing, then f, is that prime or double prime, is positive. I think that says, I don't know, I think it's supposed to be f prime of x. Alright, so we'll say f prime of x is positive. So that's true. Anytime a function is increasing, we know that that's where the first derivative is positive. So that is true. Okay, I'm not sure if that's an f prime or f double prime, but we're going to say it's f prime. Alright, number 8. Find the relative extrema for, and it gives us the equation. So relative extrema are our maxes and mins. We know we do that by finding the derivative and setting it equal to 0 for our critical points, or where our derivative is undefined. Okay, so our derivative is negative 15 x to the 4th plus 15x squared. I'm going to set that equal to 0. I'm going to factor out a 15x squared. I would have negative x squared plus 1 left. Set each factor equal to 0 and solve. So this one is just going to be x equals 0. This one, negative x squared equals negative 1. That means x squared equals 1. So when I take the square root, x equals plus or minus 1. So we know these are our critical points. So now we need to put our critical points on our sign chart. So I have negative 1, 0, 1. And we're going to plug numbers into our sign chart, and we're going to plug them into our derivative. It doesn't matter if it's this one or our more factored one. So I'm going to plug negative 2 in. When I plug negative 2 into these x's, I'm going to get a negative answer because of this number right here. When I plug in a number between negative 1 and 0, like negative 0.5, into either one of these, I'm going to get plus. I'm not going to go through the math and show you, okay, but you could do that. When I choose a number between 0 and 1, like 1/2, plug it in, I get plus. When I choose a number greater than 1, like 2 or 10, I get minus. So, f of x has a min at x equals negative 1, right here, because f prime of x went from negative to positive. F of x has a max at x equals 1 because f prime of x went positive to negative. Okay. Number 9. Alright, number 9. Determine whether the mean value theorem can be applied to f on the closed interval from a to b. And if it can be applied, find all values of c in the open interval such that, and then it gives you this right here. Now, these problems, people forget what to do all the time, but it tells you what to do. It tells you to find this it tells you to find f prime and then set them equal to each other. So first we have to figure out if it can be applied. So I put the mean value theorem here. It says if f of x is continuous. So I have x cubed plus 2x. It's continuous on this interval. What is? X cubed? No, we don't know, but we know it's continuous always. Is it differentiable? Yes, when I take the derivative, it exists on this interval. Okay, so first of all, we have to make sure that it applies, and then we're going to do what it says. So let's do this part first. Let's find f of b minus f of a. Okay, so here's my a, here's my b. So I'm going to say f of 1 minus f of negative 1 all over 1 minus negative 1. Okay, well, let's see what that's equal to. I'm plugging 1 in. 1 plus 2, that's going to be 3. Minus, when I plug 1 in, negative 1 in, I'm going to get negative 1 minus 2. So that's going to be negative 3. All over 2. So that's going to give me 6 over 2, which is 3. Okay, so I did this left-hand part. Now let's do the right-hand part. Find the derivative, set it equal to 0 and solve, and that's going to give me my c. So my derivative of this is 3x squared plus 2. Set that equal to 0. Okay, we're going to solve. So I get x squared equals negative 2 thirds. Is that right? Well, oh, I messed up. Hang on. Instead of setting it equal to 0. Okay, I found the derivative. Now, it tells us to find the derivative and set it equal to my answer. I was getting carried away there. So here's my derivative. 3x squared plus 2. Set it equal, on the derivative, set it equal to what we just found. 3. So now I'm going to solve for x. 3x squared equals 1, because I subtracted 2. X squared equals 1/3. Solve by taking the square root. I get plus or minus the square root of 1 over 3. Okay? So, do I need both of these or just one of them? Okay, I want the ones that will fall between negative 1 and 1. Okay, so square root of 1 over 3, that falls between there, negative square root of 3, yep, so that is my answer. Okay. Number 10, find the points of inflection and discuss the concavity of the graph of the function. So we should know that points of inflection come from the second derivative. Okay, so I'm going to find the first derivative. 3x squared minus 12x plus 12. My computer's acting up. I don't know what's wrong with it. I'm not going to do anything with that. I have now the second derivative is 6x minus 12. Set that equal to 0. And I get 12 equals 6x, so x equals 2. Now that's a possible point of inflection, but we don't know for sure. We have to put that on a sign chart and make sure that it changes signs. So when I choose numbers, I'm plugging these numbers into my second derivative. So when I choose a number to the left of 2, like 0, I get negative. When I choose a number to the right of 2, like positive 10, I get positive. So, since it changes signs, I know that 2 is a point of inflection. So I'm going to write f of x has a POI, or point of inflection, at x equals 2, because my second derivative changed signs. We don't even really care what it changed to, we just care that it changed signs. Then it says, discuss the concavity. We know that it's concave up my second derivative is positive, concave down where it's negative. So f of x is concave up from 2 to infinity because my second derivative is greater than 0 or positive. And we know that f of x is concave down from negative infinity to 2 because my second derivative is less than 0 or negative. Okay, so that's problems 5 through 10. I'll do 11 to 15 on the next video.